Welcome to Industry Innovations. We're in Chicago. We're going to talk about reality capture and mapping, how it improves cost, time, quality, and safety. And we're even going to fly an autonomous drone. And all of that starts right now. Welcome to Industry Innovations. Welcome to Chicago. This is our test bed. I'm your host and head of Oracle Industry Lab, Burcin Kaplanoglu. Well, we have three experts with us today: Colin Romberger with Skydio, Mani Golparwar with Reconstruct, and Jennifer Seward with Pepper Construction. We have done a data experiment. We captured reality, we mapped it, and we processed it. What you're going to experience is how these technologies work. So today, what you're going to see, some of these are applicable to heavy asset-intensive industries, and could be manufacturing, could be a bridge, could be a film set even like this. Let me give you some examples. If it's construction, we could use reality capture and mapping for progress reporting. If it's for utilities, it could be for maintenance. Well, you can capture what's in reality and then prioritize those assets that require maintenance. If it's a factory floor, it could be used to make sure that whatever changes you do on the factory floor, you can plan it properly. If it is for oil and gas, it could be for their shutdown turnaround process. That's the process where they shut down the facility, they do maintenance, they make some changes, and every single day counts because they need to go back to operations. And for a film set like this, it could be used to make sure everything is in the same spot the next day when you film it. Well, these asset-intensive industries use these techniques, and until now, there hasn't been a good guideline to actually help them to figure out what use cases match what techniques. Now I'm going to explain what we did. For LiDAR, we use stationary LiDAR, mobile LiDAR, structured light, and robot-attached LiDAR. For reality mapping, we used manual drone, autonomous drone, 360 camera, and a phone. Now, when we use all these techniques, we collected all this data, and we processed that on the cloud. And we even did a cost and time study. We mapped all these processes to the actual use cases that are used in the industries. That's what the guideline is about. So guideline provides us all the details of how this data is captured, what it took in terms of cost, time, and how they map back to the use cases. Now, what I'm going to do next is I'm actually going to walk towards Colin and Tiffany. They are this way, where we are going to actually fly an autonomous drone, and you're going to experience one method of how we actually capture this data. Follow me. All right. Hi, Colin.
Hey, Burcin, how are you?
Hi, Tiffany. Great to see you guys. So, can you explain to me what we're going to do right now?
Yeah, absolutely. So we've got a new mode for our 3D scan software called Indoor Capture. And so what we're going to do is we're going to set it up, and we're going to capture a space here inside the lab, utilizing our vision-based autonomous software to get complete total coverage of whatever it is that we're going to look at from every possible angle, so that you have the best data set possible to then put into photogrammetry software for reconstruction.
Awesome. So Tiffany, you fly manual drones too. So how is it different than, flying it manually?
Yeah, so in a manual flight, you actually have the operator with the controller mapping waypoint captures along the way, which can be very time consuming. On the other hand, with 3D scanning, you have the operator which simply sends the drone out to perform autonomous way capture missions. And what that does is it can capture any angle at any time and in less time as well.
That's awesome. So can we see how it works?
Absolutely, yeah. All right. So we're already set up, ready to go. We're in our 3D scan software. I'm going to go ahead and hit begin flight. And our menus are going to walk us right through the entire setup, which is really quick and really easy. So I'm going to go ahead and give this a name, just so that all of our images get stored in the right location and are easy to find on our SD card after we're done. Or if we upload these to the cloud, they can automatically be pulled then to whatever other software we want to use later on.
And are you scanning those pipes? Is that what you're going to do?
Yeah, the pipes are going to be inside of our area, but it's actually going to be a little bit cooler than that. We're going to have the pipes as well as this beam framework around here with the overhangs and everything else. So you can really see the power of what the software can do.
We're going to say these are the boundaries, and then drone is going to figure out how many images it needs to take. Is that what's going to happen?
Absolutely, yeah. I'm going to go ahead and set up the box, and then I'm going to let Tiffany go ahead and execute the flights so that you and I can talk and you can see exactly what the drone's doing on the big screen.
Awesome.
All right, here we go.
All right, the drone is launching. It's getting in the air.
Okay, so I'll go ahead and set up our box. So all we have to do is go ahead and set a floor and a ceiling for our capture area. So the floor, quick and easy, that's that orange plane right there. Our ceiling is our green plane, so we're going to take that up above our steel beams that we've got in the lab. Now we're going to go ahead and we're going to set up a box. So I'm going to come outside of the steel beams and set a pillar here.
So you're digitally setting these boundaries?
I am, yep. I'm digitally setting the boundaries. And it's as simple as just flying a quick box pattern, dropping those posts as we go.
So the drone is in there, and this is what we're seeing live stream back to us.
You've got it.
There you go. Here's us.
Here we are. Last pillar set.
Yep.
So here's our nice little box. There's a lot of other different settings and things we can use to modify this. We can say that whether or not we're interested in just what's inside the box. We can also, if we're in a room and we want to get the entire room, the entire interior space, we can also say, let's turn around and look outside the box as well. And then we can also set up different safety margins. How fast do we want it to fly? Are there areas that we don't want it to go past as far as these boundaries? So it's really flexible depending on the user.
Can this be used outside?
Absolutely, yeah, indoors or outdoors. Indoor scan's our newest feature on 3D Scan, and so that's what we wanted to show you today.
Awesome.
Fantastic. So I'm going to go ahead and click through the last of our settings here, and then I'm going to go ahead and give this to Tiffany, and she can go ahead and send it off. So Tiffany, that's all yours. And she's going to hit begin exploration, and that's still only going to take about 5 or 10 seconds because we're using all of our navigation cameras on our drone. So not just the one in the front, but actually all the ones around the body of the drone to look at the scene. And you can see it was a matter of seconds where now it knows what the scene looks like. And we've got some a quick preview of how many photos it's going to take using the settings that are up there. And of course, we can always modify those settings if we'd like to.
So you set the boundaries and you gave some parameters about, what overlap you want because it's actually showing there, and it said it needs to take 65 images. So this is all autonomous. It calculated that. And what are these red boxes?
Yeah, so the red boxes, now Tiffany went ahead and launched the flight. So these are all the photo locations that the drone's going to go to take its image. So when it made its reference model early on, it built a quick little frame mesh of whatever it saw with our navigation cameras. And now the flight plan, based on the settings, has identified these as the photo locations that it needs to capture.
Awesome. And just to be clear, Tiff is holding the controller, but she's actually not.
She's not doing anything.
She's not doing anything, right?
Hands
so
off.
This is all fully autonomous. Like, it decided that it needs to take a picture of that, so it's actually over there and taking those images that it will collect.
That's right.
Wow. So, which industries use these fully autonomous scanning techniques?
Yeah, so it's becoming very popular with a lot of our customers. Right now we're working with DOTs. We have over half the DOTs in the country, so about almost 30, I think 30 right now, DOTs that are using them for bridge inspections. We also work with a lot of utility customers that are using them to scan dams and large concrete containment domes to look for very small cracks in those structures that are critical as far as the health of those facilities. Also large cooling towers at some of their other generation facilities. We have manufacturing facilities that are using these indoors to look at very hard to reach, ceiling mounted cranes and other equipment that need to be inspected on a regular basis. We have inventory use cases where they're using this type of scanning to collect the image data sets that they'll then throw through different analytics software. So yeah, it's really endless as far as the application.
Wow, that's awesome. So when we did the data experiment, we used this technique where we put all the boundaries. We actually told the computer vision that, well, we need these 4 boundaries and go and scan it. So it actually did 3 flights because it's such a big space. So
Sure.
it decided, and then we also, gave it the resolution that we wanted to do that. And looks like it's done.
It's done, yeah. All
Wow, that
finished.
was really quick.
So Tiffany's going to go ahead and just bring it home. She'll hit return to launch, and the drone's going to go ahead and fly itself back to where we took off.
So just to be clear, all she did was begin, and she did return home.
That's it.
And everything else is now, photos are taken. What happens next?
So the photos now are stored on our SD card, and so the customer has 2 options. They can either take those photos off the SD card manually, if that's what they'd like to do, or they can automatically sync them with Skydio Cloud, and then we have a host of APIs that will allow them to pull that data into whatever post-processing software they'd like to use. So that might be photogrammetry, it might be change detection, whatever the case might be, they're able to do that and leverage the power of the post-processing software.
Well, we have been doing that. So one of the things we did is we actually used these steel structures and we put rust decal.
Yeah.
And one of the things we're working on is flying the drone fully autonomously, capturing that data, and we're using Oracle's vision services to recognize rust. And what we are working with customers is, well, if it's above a certain percentage of confidence, because what it does is when computer vision recognize, it says a confidence level.
Right.
So far we're discussing if it's above 90%, then that triggers an action, and then it is going to another Oracle product, which is where utilities manage their work orders. So it automatically generates that. And as these days we know that, especially infrastructure in North America, there's a lot of help we need to make sure
absolutely.
that it is up to par, at the level that we want it to be. So these are extremely useful.
Absolutely, yeah. Wherever we can provide an end-to-end solution, we're excited to be a part of that, and it's really exciting what you guys are doing.
Awesome. And I want to say thank you, Colin, and thank you, Tiffany. So I'm going to walk back in there. I'm going to meet with Mani and Jennifer, and we're going to have a conversation about the actual experiment we did and how it relates to their day-to-day work.
Fantastic.
Well, that was quite interesting. We were able to show you how fully autonomously data can be captured. And as I'm walking in to ask questions to Mani and Jen, what really made me think is the level of autonomy. Look, everybody is concerned about autonomy coming to our lives, what it means for our workforce, but we do truly realize that there's labor shortage, there's skills that's required to do this. So these techniques are really going to help us. And for next, we're actually really going to discuss the details of the guideline. Follow me. Hi, Jen.
Hi.
Hi, Mani.
Hi.
Thanks for joining us.
Of course.
Let me take my seat. All right. We have 2 experts now, and Mani Gopalwar is an expert in computer vision and AI. Jennifer Suet is an expert in construction. And we worked together and did a data experiment. While we did the data experiment, it was about reality capture and mapping. These technologies improves cost, time, quality, and safety for asset-intensive industries. We're providing you to link to download right now, so you can go and read it. And I also want to remind all of you, you can enter your comments now or after, and we'll be able to respond to them. Now, the first question is to both of you. If you were to do a 30-second elevator pitch of what we have done together, what would that look like? Jen?
This experiment took a wide range of technology from a hardware perspective that are leveraged to capture reality, whether that's a space or an object, put them all up against each other in the same exact space, put them through the same software, and compare them to each other. This hasn't really been done before, and it can be overwhelming, the options. So this was really a way to compare all of those.
Mani?
Absolutely. As Jen pointed out, this is the most comprehensive experiment that's been done to date that puts together a guideline on how you can match your use cases to the right tool with the right resources you have available to you in terms of team, time availability, and what processes you have to take advantage of to satisfy your needs.
And the next question is more personal question. Why did you participate?
So when, all the tools that we were testing in this experiment are ones that either myself and my company are either using or interested in using. And we've done our own experiments internally, but in very unique, isolated times, but also not all together. So it was really nice to take a bunch of experts in the industry, put us all together and compare them, because this information is going to be helpful for me in my day-to-day job too.
And money?
Absolutely. I mean, all the time we see a range of different reality capture tools that are being used on the job site, as Jen pointed out. You see laser scanning devices, you see mobile laser scanning devices to drones, 360 cameras and phones. And oftentimes people come to us and say, which one of these tools we have to be using to solve these specific use cases? And the first question that we ask them is, what resources do you have available to you? How many people you have? How much time you have to allocate to them? And what kind of tolerances you're looking for to satisfy those use cases? And we usually make recommendation on the process, but we really wanted to put all of them on the same page, as Jen pointed out, and have one comprehensive guideline that you can go to and say, this is what I have available to me. These are the problems that I'm trying to solve. How can I maximize the opportunity we have with the tools?
Yeah, the questions that you mentioned, we're asked all the time, whether it's internally or someone externally wanting advice. And we could spend all day talking about this. So having this guide, be able to give people a starting point, is really powerful.
Actually, we're the same. So we've been running the lab for 4 or 5 years, and we got asked the same question. Every time someone walks through these doors, says, well, these technologies exist and they are applicable to not just construction. It is to oil and gas, it's to manufacturing, it's to even filming. Film studios actually use reality capture and mapping. And what we have done is we mapped everything, we processed the data, we made sense out of it. And this was, one of a kind. So want to ask you about, how is this applicable to your day-to-day work?
Yeah, so my role at Pepper is really helping lead how we implement technology as a construction manager and general contractor, and how do we use that in our day-to-day projects on our job sites. Mm-hmm. So when I look at this study, just like we talked about earlier, I'm constantly asked, what's the right tool? Is there a silver bullet? How do you
and there's no silver bullet.
There is no silver bullet, which this proved.
Yeah.
And so every day there's something that we have to do to take existing condition, whether it's a green field or an existing building, and do something with it. So we also have projects all over the country and people with different expertise. So I have to constantly navigate all of those factors and figure out what is the right tool for us to use for the right use case, which I know you mentioned use case, and that's probably the most critical piece of this.
And it's also applicable for modular, right? Because for the audience, construction, manufacturing, other industries, they use this, but things don't really need to be built on the site. It could be built somewhere else. You still need to know the site conditions. You still need to understand how to implement that. And money?
Yeah, for us, we constantly get asked, in terms of recommending what tools people have to be using, and some of those questions that we mentioned before. But I'd like to share a slightly different perspective. It's also important to understand who's going to be using that data, right? At the end of the day, you're probably putting that in front of your superintendents, maybe you're putting that in front of your project managers, or maybe as part of a construction coordination meeting. And the question is, can you offer maybe a consistent experience to all of them, regardless of the form factor of the tools you've used, right? Everyone knows the street view experience. Everyone is familiar with that idea of walking through images and getting a sense of the space, and through the type of tools we've used, perhaps measure the scene, annotate it, and use that for coordination. So we wanted to see how we can streamline that process that demonstrates, regardless of the type of use you use, we can actually generate a consistent experience that becomes familiar to everyone. It helps with adoption of the cases that Jen mentioned.
Absolutely. So we mentioned construction a few times, and I mentioned other industries. In your view, what industries or which industries this will actually be applicable to?
The short answer is all.
Okay.
So when you look, we've worked with artists and curators, because if you think about it.
Like museum work?
Yes. So if we're, I know we're in construction, but think about if you are an actual museum and you're trying to make sure the artwork can get through to that space, or looking at lighting. Think about yourself in your home. Imagine you order a couch and you want to make sure it fits, and sure, you can measure the dimension, but what does that look like from a scale to industrial to mining? There's so many industries that you can use this for. It's unlimited opportunity.
Yeah, and not just every type of project, but over every phase of projects that we can get engaged in, right? Jen and I have always discussed, the opportunity of using these tools and processes for project pursuits. Then you get into the pre-construction phase where you want to have, a mapping of the existing facility, maybe a brownfield project. And you get into the construction phase, all kinds of use cases. You use it for quality assurance, quality control. You look into it from a safety perspective, progress documentation, of course, and then all the way to commissioning phase. If you have a project that's being driven by a 3D model, 3D BIM, you probably want to go ahead and update that to reflect the as-built conditions, right? So that's where a lot of these tools can shine across different phases of a project.
Awesome. So this experiment was done indoor.
Mm-hmm.
How would it be if we did it actually outdoor?
Yeah, so, when you go outside, you're looking at an environment you can't control. So you have to think about weather, you have to think about lighting, all of that, where, when you're in indoor space, you can control that. But also the use cases potentially, and almost always, are different. So for example, if you're looking at, documenting landscaping, could you use a laser scanner? Absolutely. But does that make sense for what you're trying to do? So I think the big difference is just the use cases are different and the environment is different. So you have to plan a little bit more and really think through what you're trying to capture.
Yeah, I mean, the key point that Jen is pointing out to is that planning, right?
Yeah.
Planning. You always want to know what you're trying to solve, what kind of tools you have, and what kind of resources you can leverage to solve that problem. Outdoors, there's some form factor of these tools that are better for that. But again, it's always a question of resource. If you can't afford to operate a drone, given the restrictions that are enforced, maybe you look into autonomy that you get from that type of platform, all the way to a case where you say, you know what, I don't have anything except a smartphone with one of our people on the job site. What guideline, what instructions I can offer them to maximize the tool and the usage that they can get off of it. But I mean, your question was partly about outdoors versus indoors. What has been very fascinating that Jen and I have discovered, especially with the expertise that her team has brought on board with this experiment, was that there are many areas indoors that are extremely challenging. When you have dense MEP systems, mechanical, electrical, plumbing, and you have a short time span to go inside the facility and do a capture, pop up the false ceilings and do a capture, all the way to an open space like the one that we used, right? So it really varies based on what kind of systems you're trying to capture as part of your process, what density you have in the site, and how you can best plan for that process.
Well, and the other thing when you think about outdoor versus indoor is how do you set control and make sure that what you're capturing is accurate and aligned to all the other things you're probably layering on to coordinate. And so when you go outside, that's another layer of complexity. What's something that's going to be permanent? If you're in a green field and you have nothing you can tie back to, you might have to create some permanent monuments to help, really tighten up that registration. So those are things too that we have to think about as we're, looking at those.
Exactly.
pieces.
One of those insights that we've learned was to go back to project execution planning, right?
Yeah.
When we start with the design phase, envision the moment in time that we need to bring in these reality capture and mapping capabilities and see if we can put them all in the same coordinate system. So you can always see what is there versus what should be there.
Planning. Goes back to that. So no matter what we do, no matter what tool you use, whether it's a stationary LiDAR or a phone, we still need to do that. Now, Mani, you're an expert in computer vision and AI, and I really want the audience to learn from you the difference between reality mapping and reality capture. Also, if you can explain the process we use, I think that will be really helpful.
Absolutely. These terms often get used interchangeably, but I'd be more than happy to clarify. What we mean by reality capture is the process of taking images or perhaps videos and figure out where they have been captured against a reference point. And that reference point is typically a 2D drawing. So think about the blueprints, a 2D drawing you have on the job site, and all you're trying to figure out is, can I automatically or manually pin every video frame, every image against that floor plan? That's what we dominantly call as reality capture. Now envision that input going to some form of 3D reconstruction for the grammetry process by which you generate a point cloud, by which you generate the mesh model, and perhaps generate the floor plan. That's what we call really mapping. Taking in the same type of input that you typically do for reality capture and use them to map indoors and outdoors. Now, with certain devices that we use as part of this experiment, laser scanning devices, mobile scanners, structured light devices, you have the ability of getting that point cloud output that is dominantly relevant to reality mapping from the hardware piece, of course, with a number of software components to it. But what was unique here was we wanted to demonstrate that with images and videos, you can generate consistent experience that comes to you at different resolutions. You would pick and choose which one of these tools is most applicable to that use case, but map the indoor and outdoor in 3D and 2D.
And when we did this experiment, we were able to capture data in 8 different ways, then process it in Oracle's platform, and then transferred into Reconstruct, which that was the whole workflow that we use. You and I discussed this a lot. NERF is a big topic. 30% of the papers or so these days is that looking at 2D images and creating 3D. Can you educate us, how that technology works?
Yes. So, what has been fascinating is that, the time that it takes to go from an idea, from an academic perspective, to a prototype and solution is getting shorter and shorter.
No more years, right? I mean, we've seen since December, right? The generative AI and how things are.
I mean, it's been fascinating, watching the growth of many concepts that came from deep learning and now neural radiance fields of NERF field has been really fascinating. The ultimate goal is, provided with a number of images and videos, how do you very quickly and accurately map a scene in a three-dimensional environment or in a two-dimensional environment? So NERF is a body of algorithms that blends in computer vision with a number of more modern machine learning algorithms with the intent of generating the same experience. The form factor of the output that you get from NERF is different from conventional image-based 3D reconstruction techniques. But again, if you look into it from a practical perspective, the idea is, how do you quickly and very accurately generate a photorealistic map of the space provided with these images and videos? So it's all reality mapping.
Yep. So what we're talking about is we could take multiple, some pictures and then have it processed with AI and eventually turn it into a 3D space.
Absolutely. I mean, one thing perhaps I should highlight is, if you think about 360 cameras, they offer you the most immersive experience from different form of reality capture tools that are out there. You can plug that into an image-based reconstruction technique and generate an immersive walkthrough experience. Mm-hmm. You may not be able to do that with a smartphone video camera because you're limited to what you capture with the device. The essence of looking to these NERF techniques is to see if it can generate the same immersive experience, but with a different form factor of input. And yes, it goes back to your point about reality mapping.
Absolutely. So want to go back to you, Jen, and the question is more about, we did a cost and time study to really measure, what it takes to do it and the cost of it. And then we actually link it to the use cases. So can you share your thoughts on the time study first, and then we'll go to cost next?
Yeah, so what was really great about this experiment is when we looked at time, we didn't just look at the actual time of the machine to do something. We looked at the human element. So when you look at automation versus a human having to capture it using the hardware, there's a time difference. And what's interesting too, when you look at automation, that human doesn't necessarily disappear, but they can do something else. So you in theory get that time back because you're doing something else, even if your body's still on site.
So we're selling automation here, right? We're selling that humans are still there.
They're still there.
They're helping us, and this is what it will actually do for you.
Yeah. I mean, imagine we have labor shortages. We have people being overworked. So it's not about taking away jobs. It's about giving them more time back in their life.
Exactly.
Yeah.
I mean, every project team that we talk to, they're always understaffed. And I'm sure Jen can relate to this pretty well. And what we wanted to do is to look into how we can generate actionable insight as fast as we can, as opposed to spending more time out in the field, right? So the essence of having a guideline in place is to minimize that time so we can use that time for something else that absolutely needs attention too.
And when you look at the time, you have the capture time, but then you have the processing and getting that output. And you were talking about this earlier, where as soon as we're capturing something, we need it right away. And so that getting to the end user, and the end user isn't always myself. It could be our team, our client. So we need to get it to them as quickly as possible and in a format that works for them in that use case. So the time from capture through completion is critical, but each tool has different factors that play into that.
And as Jen pointed out, this was actually one of the most unique components of this series of experiments that we did, because we looked into what it takes to set up, what it takes to perform the capture, what it takes to transfer the data to the processing engine, process that, even make that ready for view experience. And this was the first time that, to our understanding, a group of people were actually looking into it end to end.
And human skills, right? We learned it firsthand. The skills of the person is really important when you're actually using these even though we use some automation, we use some technologies which are commercially available to help us. When it comes to time study, I found it quite interesting to see that, when humans did improve with repetition in terms of their performance and the things they did, but it couldn't really match what machines did. So this is in terms of autonomous drones, this is in terms of use of robotics. I think that was quite interesting. The other thing I found interesting was about mobile technology, the mobile LiDAR, how we were able to actually capture that. I found it quite interesting to see the performance of it and how we actually could capture. And then it went back to the use cases, right? Eventually, everything has to tie to the use cases. The next part is about cost. So if you think everything else we have done, and again, audience can download the paper and actually can read through this, what did you see in terms of cost improvement?
So, you hit it when you were talking about time. So when you look at automation, if you're repeating something over and over, you can have some kind of time savings, which obviously labor, time on a job, that all has a cost to it. But additionally, you got to look at the technology in that cost. So when you look at, let's say, LiDAR on drones or robotics, those are pretty pricey right now. Yep. But when you tie in the use case, if you are doing, repetitive work, that cost may make sense. And then what's also on the flip side is it's interesting how, when you look at 360 cameras or, other, tools like that, the costs are going down. Think about it when we used to buy external data. Now you can walk into a store and get tons of data for really cheap right at your fingertips. So, with the cost, you have to think about the labor, you have to think about the hardware, you have to think about even software, all of that combined, and it's getting cheaper. But if you think about the use case, sometimes that cost is worth it because of the end result.
Yeah. And the one I've seen, and the audience can see it in the table, is stationary LiDAR, which is used by a human, and then a LiDAR attached to a robot. Yes, the total cost of the robot and LiDAR was much more expensive initially, but as we kept repeating the process, the cost actually came down, and it kind of become comparable to each other. I thought that was quite interesting. That brings the next question. Several times in this guideline, we were able to make a point about autonomy, like what autonomy means. What will be the impact you think, these technologies coming in and bringing autonomous technologies to industries?
It's interesting. We talk a lot about, productivity, and construction's been flat and went down, but that's not, some of that can be combated with tools, but some of that has to do with increased regulation, safety, all of that. So no matter how much tech we're going to put on a job, we still have those, dynamics happening. So the more we can get more efficient, because we can't just keep adding bodies to jobs. At some point, it's not going to be effective cost-wise. Clients are demanding quicker schedules, high quality as always, and cheaper budgets. How do you combat that? So autonomy allows us to continue to get the work done, but be efficient with the resources we have. And so you look at drones, for example, there's already some autonomy in it. Think about even when you fly an airplane, right? The pilot has autopilot in some of those. So
they have it for decades.
Right. And so then when you look at scanning, and we talked about robotics, and you add those together, you're taking kind of two hardwares, putting them together. But I think we're going to see this trend continue to increase. And it's a real necessity. Why are we having really educated people, hardworking people doing mundane tasks when they came to build buildings and they want to be challenged? Let autonomy do that while they can focus on what is great about the human, our brains, and all these other things.
Yeah, the autonomous part has been pretty exciting, as Jen pointed out. There are certain type of projects and use cases that leveraging this autonomous platform for capture makes a lot of sense. We often get engaged in industrial projects, for example, data centers, projects that did not exist 2 decades ago, right? And now the amount of work that gets done every day can be somewhere between $2 to $5 million. So it makes a lot of sense for us to do capture every single day. And where are we going to get that resource that can afford walking on the job site of that magnitude and do the capture, that's where autonomy truly shines. You can, get your data and have your team members truly focus on what is that insight that we can generate off of that. The same applies to drones. What has been really fascinating as part of this experiment is we looked into operating drones indoors. Of course, operating drones outdoors have been done. The element of autonomy outdoor is rather easier because you have access to GPS that can provide you with location information. But indoors, the ability of tapping into newer forms of technology such as SLAM, simultaneous localization and mapping, can help you feel safer about the operation of these type of robots, whether they're on the ground or in the air.
And question to both of you, what's the most surprising thing you find?
So I found it really fascinating how far 360 photogrammetry has come, and the possibilities of where we can take it. In fact, when I was thinking about it, I started really thinking, man, I think as an industry, we're really underutilizing that tool. Now, it doesn't fit all use cases, but, looking at that on top of also looking at, autonomy and how that can really speed up things combined was really, really interesting to see. But I think that 360 factor, I started questioning some of my own use cases and thinking, maybe there's a different way to do it, and the result isn't that drastically different for that specific use case. Now, that doesn't mean it's a silver bullet like we talked about earlier, but I think about projects where, we might be building a store in another state and we can't really get our experts and staff there quick enough every single day. Our PMs and others have these tools that might be enough for us to get them something useful.
That's right. For me, I work dominantly on the software side and algorithms. So, what was really fascinating for me was the, putting these tools out there for test, and that, sense of thinking that, what we've been working on is actually accomplishing those goals that we had in mind. As Jen pointed out, the usage of 360 cameras or even a smartphone, being able to demonstrate that, while there's a lesser cost associated with these tools, if you use them in the right process with the right level of expertise, you can actually satisfy many of your use cases, right? So being able to, test that by experts such as Jen and her team out in the industry is truly gratifying.
But I think that's what's beautiful about this experiment and guide is I think often people get disappointed because I'll keep saying it, the silver bullet answer, but you're trying to force something. And it's like, at least if you know what you're working with and you're able to set expectations, you could go pretty far and be really dangerous with that information in a good way. And so I think that was what was really great about this experiment, just having it all in front of us.
Those are great points. Thanks for sharing. One of the things I personally found out for industries, let's say it's healthcare, with manufacturing, construction, most people look at it as, well, you can't really do remote work. You need to physically be there. You need to actually do this work, right? Mm-hmm. What we were able to prove is in this guideline as well, if you can capture the data remotely, or you can even fly things remotely, you can have robots work remotely, you can use camera feeds, and you do not even need to have people on that location. This could be a factory floor, it could be a construction site, it could be even a hospital, right? With the ability to capture that data, push it to cloud, process it, and use experts somewhere else. Well, it could be a different part of the world too. Like you could capture the data in Middle East, end of the day, and then next morning, someone in US could actually process it and see what the outcomes. And by the time they wake up, you actually will have things to do or the tasks to do. So you can really have this not only remote work, but 24 hours. I think that was quite interesting to point. Also, the technology evolves so much, like you said earlier, right? The speed of it. I think we're hearing these things, and where we came to a pivotal point that these things are really, coming to life and actually really impacting us.
But Burcin, think about where we did the experiment. So we obviously, Pepper Construction built the lab, but that was in the heat of the pandemic.
Yes.
And so we had a design team who some of them were remote, and we actually were able to, they were coming at the end of the project to do a final punch list, and we couldn't rely on everything being caught there. There wouldn't have been time to turn over the building. So we used all of this technology that we talked about, not all of it, but a lot of it that we talked about in the experiment to allow them to virtually review the building and the progress so that we didn't skip a beat. It was smooth at the end. And we actually started doing that with other projects as well. We have design partners that sometimes never work on a project that's even in their own country. And so they can get there virtually by using this data.
I mean, Jen and I have discussed the RFI workflow, request for information, right? Over the past 10, 20 years, we've automated that process using tools, right? But what happens is we still, face a situation where the contractor creates the RFI. It goes out through this digital system and the designer on the other end gets it and there's no context behind it. Maybe there's a picture, right? But putting that picture in the context of where the design issue was happening, what is really happening with respect to the rest of the system was missing. Now you have an opportunity to minimize that phone call that always happens, right? The moment that you issue the RFI, the architect, engineer who's been working on the design picks up the phone, calls the contractor, and now you're spending more time explaining the rationale behind why this RFI was actually, reported in the first place. So, being able to capture space, map it out in 3D, contrast it against 2D or 3D design, would bring these parties that are engaged in a project on the same page in terms of what's happening and what is that delta between reality versus design, so we can resolve these issues faster.
Pictures worth 1,000 words, and that proves it.
Absolutely. Well, time flies, and this just came in, so we have some questions from the audience. Looking at the questions, this is from Mike in New York, and Jen, this question is to you. What should we do when we capture data in confined spaces?
Oh, wow. That is always a challenge.
Yes.
So we talked about planning. I cannot emphasize enough how much planning you need to go into thinking about that. So if, we didn't specifically say this, but when we're using all these tools that we talked about and used in this experiment, it doesn't have X-ray vision. So when you're looking at a confined space, you have to plan out what are you capturing and how are you physically going to be able to get something to see it. So one, it might be, you mentioned earlier, pulling ceiling tiles, or think about the sequencing. Why spend all this extra time and labor pulling ceiling tiles if we can work with that client and maybe start demolition a little bit earlier to get up there? You have to think about lighting. Think about the color. We've had clients where it's all black above a ceiling, and we had to think about how does that affect what we're capturing. So, we've had jobs where maybe it didn't make sense to pop ceiling tiles. We weren't going to be able to get everything because you also have control, right?
Yep.
If you're up in a ceiling and you're capturing everything, and then you're trying to tie it to everything you captured on the floor, and you're doing them separately, somehow you have to have a point that's allowing you to bring them together. Yep. So you have to think about all of those things so that you don't waste time and energy on something that maybe doesn't give you the end result you really needed.
And that's what truly made this experiment fascinating. Yeah. Working with Jen's team, working with Oracle, you can actually feel and hear the real problems and start, refining your solutions so they can actually satisfy these needs.
Next question is to you, Mani, because it has to do with computer vision and AI. Can we automatically align a 2D floor plan to reality floor plan produced from a 360-degree video?
That's interesting. The answer to that is yes. Over the past few years, we've worked on a solution that can take in 360 videos or any sequence of 360 images. It automatically generates a point cloud and a floor plan. This is strictly by using that video as an input. But imagine you provide a 2D drawing in form of PDF. What our solution is capable of doing is to automatically find features, think about lines, corners, edges, that we can find between what we see in the video versus what we see in the 2D drawing. So there are always opportunities to automatically align the two data. Though the catch is you have to keep in mind that reality of the scene needs to look alike the design. So if you have significant progress that you've made on the job site, you probably have a scene that looks closer to your design, and this automation would work. In the absence of that, you may not be able to successfully use AI to align the data. But again, we go back to some of the points that Jen made. There's not one solution that would fit all problems, right? So you start thinking about this. You can go back to conventional surveying practices, use markers that we can auto-detect, auto-align, which we actually used as part of the experiment to make comparison apple to apple. But yes, that ability of automatically mapping 360 videos to 2D floor plans is something that we worked on, and we have a solution for it.
And I know you talked about, or the question was about alignment of a plan to the data. We have scenarios where there aren't even a plan, and now we have to give that deliverable. So I think one thing you think about when you capture all of this, we're seeing it visually, but sometimes you need to do something, take it that step further,
Exactly.
model out those walls, create that floor plan, and give it to our end users in a format that works for them. That's actually a big question when we have clients come to us and say, can you scan our space, or can you do this or that? And it's, all right, what is the end deliverable?
Exactly, the format of that deliverable.
Yeah.
I want to thank both of you for joining and sharing your expertise. I also want to thank Colin and Tiffany on the earlier segments, flying drones and what we were able to showcase. And for the audience, we are going to provide you the link to download again. And you can go to oracle.com/innovation. That is our website for the lab. And if you want to watch this episode and the previous episodes, please go to oracle.com/connect. And if you didn't watch this live and you still want to comment, you can do that. You can actually provide comments to us and we'll be able to reply to you. Well, want to thank all of you for joining. Please give us a like, subscribe, or follow. We will be back with more episodes. See you next time.